Hello everyone and welcome back to section 2.6. This is day 1, which is proving angle relationships. We got a couple of postulates and theorems to start us off. So our first postulate is the protractor postulate. That says that given any angle, the measure can be put into one-to-one correspondence with real, 2 L's for some reason, numbers between 0 and 180 degrees. That's just saying that no matter the angle, you can measure it from 0 to 180. Easy. Postulate 2.11 says that is the angle addition postulate. It says angle or D is the interior of angle ABC if and only if the measure of ABD plus the measure of DBC equals the measure of ABC. So if you imagine an angle like this is ABC, C. Then D is on the interior if you can add ABD and DBC and get the whole angle. Cool. Theorem 2.3. If two angles form a linear pair, then they are supplementary. That just kind of comes from the definition of a linear pair, which looks like this. Those two angles will make up a straight line, which means that they are supplementary or add to 180. Great. Cool. Next page. Theorem 2.4. If two angles form a right angle, then they are complementary angles. This is very similar to the last one, but pretty much if you have two angles that add up to 90 degrees, like so say 1 and 2. 1 and 2 add up to equal 90 degrees, then they are complementary angles. They make this right angle right here, so they are complementary. Cool. Next is theorem 2.5, which has a lot of properties, just like in the couple units before. These are just properties of angle congruence. We've got the reflexive property of congruence, which is just the same as the reflexive property, which is angle A is congruent to angle A. The symmetric property of congruence, which is, again, similar to the symmetric property of equality, which is if angle A is congruent to angle B, then angle B is congruent to angle A. And then same thing with the transitive property of congruence. If angle A is congruent to angle B, and angle B is congruent to angle C, then angle C is congruent to angle A. Or angle A is congruent to angle C. I mixed that up, but you get the point. Same thing as the transitive property of equality. Cool. Next one. A couple more theorems. If two angles are supplementary to the same angle, or congruent angles, then they are congruent. So if we know that there are two angles, so let's say this is an angle, well, I don't like that picture. I'm going to draw a better picture. Okay, so this is an angle that's supplementary to this angle. So this is A, this is B. Then another angle, C, is also supplementary to B. Then angle A and angle C are congruent because they're both supplementary to angle B. Same thing with theorem 2.7. If two angles are complementary to the same angle, or congruent angles, then they are congruent. So again, if angle A and angle B are, say they're complementary, so they add up to 90, then angle C is also congruent to angle A because they're both complementary to angle B. Okay, let's do some examples. So we need to find the measure of each numbered angle at the right. So we've got a measure of angle 2 is x, and measure of angle 3 is x minus 16. Careful with the 2 and the 3 there, that's not in the problem. So we know that angle 1 is a right angle, and these make a straight line, which has 180 degrees in it. So if this is 90, then that means the other half of this angle is also 90 because they make up the straight line, the linear pair. So we've got two 90-degree angles, and this one on the right is made up of angle 2 and angle 3. So we know that, let me get a different color, x plus x minus 16 has to equal 90. We know that these two angles have to make up this 90-degree angle. So when we simplify, we get the two x's together, which make 2x minus 16 equals 90. We'll add 16 to both sides. So 2x equals, let's see, 106. So x equals 53. Done. Or now we have what x is. Now we need to plug it back into our problem. So let's take the 53 and plug it in for x here. So instead of x now, we're going to write 53. We don't need to do any extra steps there because x is 53. And then for this one, we'll plug it in, 53 minus 16, which is, let's see if I can do it in my head, 30 something? 37? Yeah, 37. Done. Put a box around it or something. A circle. Okay, next problem. Angle 4 and angle 5. Angle 4 is 2x. Angle 5 is x plus 9. And see how they make up this straight line again. So that means they add up to 180. They are supplementary angles. So 2x plus x plus 9 equals 180. Again, we'll simplify to add the x's together to get 3x. Plus 9 equals 180. We'll subtract 9 from both sides. So let me move up here. 3x equals 171. Divide by 3, divide by 3. Let me do that in my calculator really quick. So I got x equals 57. Ooh, 57. So again, now that we got our x, we got to plug it back in to the main problem. So 2 times 57 is 114. And then 57 plus 9, which is 66. Okay, done, done, great. Next page. Now we've got our first proof. So we're going to write a two-column proof for each of the following things. So angle 1 is this one, and it's congruent to angle 3. So that's our given. Let's write that in here. Angle 1 is congruent to angle 3, given. Next, let's look at what we're trying to prove. We're trying to prove that angle WXE, so WXZ, this angle right here, is congruent to angle TXY. So this one right here. So we're going to need some angle addition here so we can get through this. Now we got our given. So the first thing we've got to do is get rid of this congruent symbol. So I'm going to rewrite this with an equal sign. So angle 1 is equal to angle 3, and that's definition of congruent. So congruence. Now I'll start my angle addition. So on my next line, I'll do angle 1 plus angle 2. Angle WXZ is made up of angle 1 and 2. So when I add them together, I'll get the whole thing. So angle WXZ, angle addition. And then I'll do the same thing with TXY. So TXY is made up of 2 and 3. So angle 2 plus angle 3 equals angle TXY. And that's again angle addition. Okay, now comes the fun part. I know that angle 1 and angle 3 are equal to each other. So instead of angle 3 here, I'm going to write angle 1. I'm just going to rewrite this, and I'm going to substitute in angle 1 for angle 3. That would be substitution. Because angle 1 and angle 3 are equal, so they're equal to the same thing. So if I substitute it, it does not change the value. Now I can substitute in, I've got my highlighter, I can substitute in this whole angle for this part. So instead of angle 2 plus angle 1, I'm going to substitute in angle WXZ, because that's the same thing as angle 1 plus angle 2. So let's go down here. Angle WXZ equals angle TXY. Oh, and I need my line here. Again, that's substitution. Oh, that's not a very straight. Oh, there we go. Not a very straight line. There we go. Now, I need to change this back into a congruent sign, so I'm going to change it by definition of congruence. So WXZ is congruent to angle TXY, and that will be def of congruent. Cool. Next problem. Ooh, fun. Angle 1 and angle 2 form a linear pair. So again, first given and angle 2 are a linear pair. It's given. Our second given is that angle 2 and angle 3 are supplementary. Cool. Gosh, I hate those lines. Okay. So we need to prove that angle 1 and angle 3 are congruent to each other. Well, angle 1 and angle 2 are supplementary, and we can tell because they're a linear pair. So, and that was that theorem. I think theorem, is it 12? Angle 1 and angle 2 are supplementary. So, and that would be if two angles are linear pair, then so. Cool. Now, if, remember that one other theorem, if two angles are supplementary to the same angle, so in this case angle 1 and angle 3 are both supplementary to angle 2, that means that they are congruent. So, angle 1 is congruent to angle 3, and the reason is if two angles are supplementary to same angle, then they're congruent. And I kind of put that in shorthand, so it'll be easier to write. But if you need to write out the whole thing, of course, then you should. If two angles are supplementary to the same angle, then they are congruent. Okay, last one. Given that BC bisects DBE, so DBE is this angle. Let me highlight it so you can see DBE. And again, that's our given, so I'm going to write it here. So BC bisects angle DBE. Given. So we need to prove that angle ABD is congruent to angle ABE. These two angles. Okay, let's get started. Well, we know that BC bisects angle DBE, so we know that angle 1 is congruent to angle 2, because those two angles make up DBE, and a bisector cuts them in half. So these were cut perfectly in half into two congruent parts. So that would be definition of bisector. Or angle bisector. Angle bisector. Cool. So now we know that angle 1 is congruent to angle 2. Done. Well, we know that angle 1 and angle ABD are a linear pair. So, because they make up that straight line. So, angle 1 and angle ABD are a linear pair. That's the definition of a linear pair. I'm going to grab a different color. Next, same thing with angle 2. Angle 2 and angle ABE are a linear pair. And again, definition of linear pair. Cool. So, remember that one theorem that we were just talking about? How if they are a linear pair, then they are also supplementary. So now I'm going to rewrite these, and instead I'm going to write angle 1 and angle ABD are supplementary. And then angle 2 and angle ABE are supplementary. And that is if two angles are a linear pair, then supplementary. Same with this one. Cool. Last step. Remember, in that same theorem, we'll kind of cross that out a bit, where we were talking about if two angles are supplementary to the same angle, or if two angles are supplementary to the same angle, then they're congruent. Well, that also said or congruent angles. We know that angle 1 and 2 are congruent because they were bisected by the BC. So, angle ABD and angle ABE are supplementary to two congruent angles. So, by that theorem, we know that angle ABD is congruent to angle ABE. And that is if two angles are supplementary to congruent angles, then they are congruent. Two angles are supplementary to congruent angles, then they are congruent. Now this is kind of a long proof, so make sure you get it all in there. And this is the end of this section, and now we're going to move on to 2.6 day 2. Thanks!